Hello Tandy TRS-80 enthusiasts! Happy September, the month in which we are celebrating all things Tandy. This is my contribution to this series. Let's assemble the Talker 80 voice synthesizer kit for the models 3 and 4. You can purchase the kit from me, but you will have to source some essential parts yourself, like this Click Speech microbus board from Microelectronica. I released Talker 80 for the Model 1 in April this year, and it was very positively received by the community. I have sold about 30 of these by now. Some folks have even made their own 3D printed cases, like this one here, which was designed by the 14-year-old Logan. Talker 80 emulates the TRS voice synthesizer and the VS100 from Alpha Products. It also features a native DeckTalk mode that is capable of producing natural-sounding speech. Talker 80 is an open-source project. Check out the GitHub repo, and the kits include the PCB and the program chips. The rest you will have to source yourself. It should take about 3 hours to assemble, depending on your skill levels. Without further ado, let's get started. The Talker 80 kit contains the PCB and a 50-pin IDC box header, which connects to the expansion port of the TRS-80. The box header goes on the back of the PCB. Also make sure the notch is facing away from the PCB edge connector. The edge connector is an expansion port pass-through, so you don't lose the expansion port for further peripherals. So let's just solder it in. I usually start with the corner pins, then checking for misalignment before proceeding with the remaining pins. An illuminated magnifier is super useful for checking for solder bridges. Next, we are putting in the dip sockets for the chips. They go on the front of the PCB, and as always, make sure that the notch is facing towards the edge connector. And with a little bit of luck, you can just flip them around like this, and you don't even need clear tape. Again, I'm starting by soldering in the corner pins, checking for misalignment, flipping it around, and then continuing with the other pins. Talker 80 comes with an audio amplifier, which is the PAM module, which is a very neat little D-class amplifier you can get for a couple of dollars on eBay. To mount the PAM module, I'm using these single-row pin headers. They break easily. You can just break them into segments of the required length. Just like so. Next, check the PAM module where there are missing holes, and we can just use our side cutter and pull out the superfluous pins. That's also relatively easy. Here is another tip. Immediately put these removed pins into the trash. They hurt if you step into them. And then we are just going to mount the PAM module on top, and we start by soldering it in from the bottom. And after that, don't forget to solder it in from the top. The stereo connectors are next. Talker 80 has 3 of these. They can be a bit difficult to put in. Don't use a lot of force. If it doesn't pop in right away, check for bent pins and try again. Just bend the pin a little bit and try again. And there you go. 2 of these are inputs. The first input is for the Click Speech daughter board. The second one for amplifying the cassette sound port from the TRS-80. And the third is a mixed line out of the 2 coming from the op amp. Next, we are putting in the PSU barrel jack for the power supply. This is a 5 volts with positive tip polarity. That always takes a lot of solder. You really need to heat the pads thoroughly. Also, there is one more dip socket we need to put in for the op amp. And here I'm using a tool that only the most advanced makers dare to use. Clear tape. So a bit of clear tape should keep the socket in place. And I'm going to flip it over to solder it in. The 2-position dip switch is used to select the initial boot or startup mode of Talker-80. With 2 switches we have 4 possible modes: the TRS Voice Synthesizer Emulation mode, the VS100 Synth Emulation mode, the DEC Talk, and the Epson mode. Talker-80 also has a reset push button, which is very useful for selecting modes in combination with the dip switch. Modes can also be changed via software, of course. We all make mistakes sometimes. Upon closer inspection, I saw that one of the pins of the push button wasn't soldered in neatly. It got bent away, as you see here, so I had to remove it. And in order to get the excess solder out of the soldering holes, I'm using desoldering wick, which does a nice job of sucking up the excess solder. So, with the PCB holes cleaned, I can try again, and this time I succeed. Now it's time to put in the potentiometers or trimmers. There are 2 503 50 kilo ohm trimmers, which are used for determining the input level for the 2 inputs, and another 101 or 100 ohm trimmer is used to control the volume of the PAM audio amplifier that goes directly into the loudspeaker. Talker-80 uses an AVR microcontroller clocked at 16 MHz, so this is the crystal we need for that. We can just put it in, and if you bend the pins away a little bit, you solder it in, and you use a side cutter to cut off the leads. For proper operation, the crystal requires 2 22 picofarad capacitors. These have a code number of 220. I'm using a magnifier glass to read the tiny numbers. And I'm just putting them in. I'm bending the leads away like this, so when I flip it over they don't fall out, and then I just solder them in. We are not quite done yet with the capacitors. There are more. Each chip gets its own 104 or 100 nanofarad decoupling capacitor, so there are 4 of these. And then there are 2 224 220 nanofarad capacitors and a 10 nanofarad, code number 103, for the audio op-amp section. And as always, we are checking our work with a magnifying glass. Alright, it's time for the resistors. There are a few of those. Looking at the bill of material, we start with R2, R3, R4. These are current limiting resistors for the LEDs, and they are 1 kilo ohm each. The power rating of these resistors is not really important. I'm using half a watt resistors, but you can also use a quarter watt or even less. After the LED resistors, I'm putting in R7 and R8, which are voltage dividers. They provide the 2.5 volts for the op amp, 47 kilo ohms. Finally, we have R1 and R9, 10 kilo ohms and 100 kilo ohms. They are part of the op amp and for the reset. Talker 80 has 3 LEDs. Before soldering in the LEDs, let's make sure they work. So I'm checking them with a multimeter in diode mode, and they light up. The last LED is a little bit difficult to install because the IDC box header is in its way. Make sure you don't burn the plastic, and then again use your magnifier glass. And if you have a decent side cutter, you should be able to cut out the lead like that. It doesn't harm to test again. The speech daughter board sits on top of the PAM audio amplifier board. I'm using stackable Arduino headers. Microelectronica calls these boards click boards, and the bus connector is called a microbus. But this module is just using an Epson speed chip, and basically it's just a SPI interface. Soldering in the Arduino headers requires a little bit more heat. I start in the corners. I have to push down the board a bit. After that, I flip it around and check for any misalignments. It's really hard to correct for it after that. Looking good. So I continue soldering the remaining pins, then use the side cutter to cut off the excess leads. And I throw them away immediately because they hurt if they get into your feet. I inspect the solder joints. You will see they look rough, so you can just use the iron to reflow them a bit so they look neat again. We almost made it. Now it's time to install the chips. We start with the AVR microcontroller. You might have to massage it a bit in order to fit in. That's the brain. The other two major chips are U1 and U2. U1 has a label. Instead of using your table to straighten the leads, you can also use this handy little tool. U1 is the address decoder. Let's just remove the label and plug it in. And U2 handles the data bus. Like the AVR microcontroller, these gate array logic chips have been programmed. Thanks to the built-in PAM amplifier board, Talker 80 can directly drive a loudspeaker. The loudspeaker port is on the back of the PCB. I'm using pin headers again. That way I can simply connect my loudspeaker using DuPont header cables. Of course, you can also solder in the loudspeaker permanently or only the loudspeaker wires, or as you like. The PAM board should be able to drive any little loudspeaker up to 20 watts in the 4 to 8 ohm range. You will also need a little stereo audio patch cable. Unfortunately, the microbus does not carry the speech signal from the daughter board, so we need to connect it like this. The big moment is finally there. We can test the Talker 80. We need a PSU, 5 volts, 200 milliamps with positive or tip center polarity. Let's plug it in and see what it does. The LEDs light up. That's a good sign. Boot sequence is working. And then they light up once more. Also good. The reset button also works. Another good sign. We don't hear anything yet, but that's okay because we need to adjust the input levels of the mixer and also the output volume. So by adjusting the potentiometers a bit, there we go. It's working. Well, at least the basics are working. We haven't checked with the TRS-80 yet. If the sound still sounds a bit distorted, we can adjust the levels a little bit more until we find a perfect setting which sounds non-distorted. and which is loud enough and clear enough. That takes a little bit of trial and error. That sounds good to me. Now let's also check the second input. Each input has its own input level mixer, so we can adjust them individually. We also want to make sure that the dip switch is working, so there are 4 different combinations. Each of the 4 combinations should produce a different boot message. Talker 80 has 2 audio output options. One is a loudspeaker over the PAM board, and then there is also a line out socket, which is driven by an op amp. So let's also make sure the op amp and line out is working. We'll have to adjust the input levels a bit. There you go. The speech is now coming from an external amplifier, and we have disconnected the loudspeaker. Also test the second input port again. It works as well. We have tested Talker 80 as extensive as possible. Now it's time to make a connection cable so that we can hook it up to a real TRS-80 Model 3, Model 4. I'm simply using old SCSI cables. I got like 50 or so of them for $20 somewhere. And I'm cutting off one of the connectors on one side with the scissors. And then I'm just using 50-pin card edge connectors, which I'm crimping on the other side. So I really recommend that you get that crimp tool. That makes life so much easier. And then I'm using an X-Acto knife to smoothen it out. Just make sure that there are no shorts in the cables like that. We reached another milestone. Let's go to the TRS-80. Let's plug it into the expansion port cable we just made. This is my cassette sound output cable, which I'm plugging into the second input. Then I'm using line out for this test. First thing I'm doing is just checking if the TRS-80 is still okay, if there are no shorts or anything. So without actually powering it, I just turn it on and I go into the cassette prompt right away. That's a good sign, so there are no shorts in the bus. Then I'm powering it up. I'm now also using the expansion port pass-through connector to connect my Freight hard drive emulator, and I dare to power on the Model 4. Will it still boot? Let's see. And sure enough, there is Freight. Alright, let's boot into LDOS. We have a basic test program. Let's run basic. There's a welcome basic program in the GitHub repo. And run. Reset has worked. It should start speaking.
Hello, I'm Talker 80. Nice to meet you. What's your name?
Success!
Hi, Mike. Thanks for purchasing me. And now I would like to sing a little song for you. May of Dick Hudmore.
Let's listen to some deck talk singing. There's also a version of Eliza, which I adapted for Talker 80 to use the Epson or deck talk mode, so that sounds much better than the TRS talking Eliza for the Model 1. That's the next one you can try. It's also in the GitHub repo.
TRS Talker 80 initialized. Epson mode. Non-blocking speech. Native Epson mode. Hello, I'm Eliza. What's your problem?
So as I said, I connected my cassette port sound output cable to the second input, and let's give that a check too, and enjoy a round of Galaxy Invasion Plus with sound. Alright guys, we reached the end of the show. Thanks so much for watching. On the last day of September 2020, you watched the birth of a new Talker 80 voice synthesizer for the TRS-80 Model 3, Model 4. Maybe next year there will be another video on my channel for September 2021. Until then, all the best and keep your TRS-80s running. Bye.